So hi everyone, my name is Valerie Darling. In this presentation, I'm going to go over the metadata scheme Darwin Core. And specifically, I'm going to discuss what Darwin Core is, its history, the elements, its semantics, where you can find it for implementation. I'll show you some examples, and then we're going to talk about the importance of Darwin Core. And lastly, I'll show you some organizations who have successfully used it for their data. I'm going to start things off a little bit differently. First, I want to set the scene. Imagine you're an ichthyologist, aka fish scientist, and you've just moved to Texas because who isn't? And you've come across what your colleague tells you is a common Texas fish. You and your colleague want to study it, its environment, habitat, which Texas bodies of water can be found in, and if pollution is endangering the species. You call up colleges, universities, and museums to see if they have specimens of the fish. You want to know if they can provide you with any information that will help you in your research. Some people help you out easily. They know that the fish you're looking for, Oreochromis aureus, is more commonly called a blue tilapia, but other people you interact with only have tilapia aurea in their collections, and so they tell you, nope, sorry, they can't help you. Some places have records of the fish in question, but their records aren't digitized, and with their small staff, they tell you it can take a few weeks to get back to you. One place you called didn't have records beyond what was recorded on their specimen jar label. While you compile your research, you worry that the time you're losing finding all the information is taking time away in ensuring the safety and health of the bodies of water, and by extension, all the animals within them. Oh well, you think, that's just the way it is. Well, fish scholar, not anymore. Don't settle for disorganized data when you can have Darwin Core data. What's Darwin Core, you ask? Well, let me tell you. Darwin Core, abbreviated DWC, is a metadata scheme intended to facilitate the sharing of information about biological diversity by providing identifiers, labels, and definitions. Darwin Core is primarily based on the observation, specimen, and samples of taxa, or taxonomic groups of any ranks, such as species, families, or class. Before we can talk about Darwin Core, we have to talk about the organization TDWG, which is now known as Biodiversity Information Standards, parentheses, TDWG. Their mission is to, quote, promote the wider and more effective dissemination and sharing of knowledge about the world's heritage of biological organisms, end quote. To help in this endeavor, a working group was tasked in creating the first ratified Darwin Core scheme in 2009. However, Darwin Core got its start in the late 1900s, about 10 years before it was made official. The main goal of the scheme was to offer a stable yet flexible framework for biologists, scientists, analysts, and others to compile, organize, and standardize biodiversity data. Okay, so Darwin Core is a scheme for metadata about biodiversity, but what does that mean exactly? Well, Darwin Core provides a glossary of terms like identifiers, labels, and definitions to keep a consistent vocabulary among scientists when talking about biodiversity data. Because the main goal of Darwin Core was to be simple and flexible, two types of Darwin Core standards were created, simple Darwin Core and generic Darwin Core. What makes simple Darwin Core simple is the fact that it only has two dimensions, rows and columns, which are attributes and their values. With simple Darwin Core, all information can be contained within one spreadsheet. When more information is needed, users can continue with generic Darwin Core, which adds two additional categories to create relational data. You can see how that looks with the table here. Now, I've mentioned that one of the main goals of Darwin Core was to be easy enough to be used across a wide variety of biodiversity applications and across different biological occurrences. So its flat rows and columns data checks that box. What makes Darwin Core flexible, the other main goal, is that there are almost no restrictions. In simple Darwin Core, there are no required fields. Instead, it lets the users of the scheme determine which type of information they want to share with others. Now, though there are no required fields, there are some rules, 10 to be exact. You can see the 10 listed here. I won't go through them all, but you can see that most of the rules are pretty easy to follow, such as no field name may be repeated, which contribute to Darwin Core being so widely used. There are a few rules I want to talk about on this list that will actually bring us into this next section of the presentation. And so I want to start out with Rule 5, which states the DC type field to provide the name of the Dublin Core type class. So Darwin Core is an extension of Dublin Core and contains a glossary and set of terms that might be familiar to those who work with Dublin Core. So if we look at the Darwin Core Quick Reference Guide, we can see an easy-to-follow guide that explicitly tells us the names, identifiers, definitions, and classes of elements. This screenshot of the guide shows us what Rule 5 is referring to, namely that when creating a Darwin Core record, the type field must be populated by a Dublin Core type class. This image is also a great example of how the organizers of Darwin Core did a really great job of making the terms very clear. The guide gives an identifier link, which, when clicked, will take the user to the web page of the authorizing entity. In this case, we would be routed to the DCMI. Luckily, though, the Darwin Core team has put the DCMI definition of type into the Darwin Core quick reference guide, so we don't have to go back and forth. It also gives us a definition. This definition helps with confusion, ambiguity, and misuse of data. And for Darwin Core, the type field should be populated with the nature or genre of the resource. The comments section gives more clarity to the definition, and in this case, explicitly states that the value comes from the DCMI. This was already stated in the identifier row, but it just provides more guidance. And then lastly, you can see that they even provide examples, which is very helpful, especially for someone like me who has never interacted with Darwin Core before this. So even though there are some terms that come from Dublin Core, Darwin Core does contain its own sets of terms and vocabulary as well. The best example would be the basis of record field, and this field is explicitly mentioned in the 10 rules as rule number 6, which states, use the basis of record field to provide the name of the most specific Darwin Core class, e.g. event, living specimen, etc. So this is another screenshot from that same quick reference guide. Because we've already been through one, you can probably see the differences between the two. Here, the authorizing entity is Darwin Core because they created the terms and vocabulary for the field. And obviously the definition has changed because we don't want differently named fields to capture the same type of information, right? Then again, we get a comment and some examples. Now this field, basis of record, with its examples of preserved specimen, fossil specimen, etc., are specific to Darwin Core and help others quickly determine what type of record they are looking at and are specifically helpful in the biodiversity arena. This field adds additional information that is specific to the work being done, and that makes it very important and useful. If we were to create metadata about our collection using only Dublin Core, we would have technically correct information on our collection, but using Darwin Core adds a higher level of specificity that is relevant to the work and research conducted. Some other interesting semantics, or at least interesting to me, about Darwin Core is that they specify multiple controlled thesauri, RFC for language, the Global Registry of Biodiversity Repositories, and even the Getty Thesaurus of Geographic Names, among others. And in some instances, Darwin Core suggests using a controlled vocabulary but doesn't specify which, and states, quote, recommended best practice is to use a controlled vocabulary. So I've been using the quick reference guide that is provided on the Darwin Core website. That guide isn't actually part of the standard and information you would get when you decide you're ready to start using Darwin Core. Darwin Core is available via text, XML, or RDF file from the GitHub repository. And here's what a simple example of a Darwin Core record would look like in XML that's taken directly from the Darwin Core website. In this example, there are no repeated fields, but obviously depending on your record, you can have a really long XML record that would get even longer with the 2 additional relational categories. However, like I mentioned earlier, simple Darwin Core is simple, and organizations have created Excel templates that allow users to input data into Excel using a software they probably already know, and then uploading that data into another tool that will read and display the information in a different way. This example is from the Global Biodiversity Information Facility, or GBIF, which brings me to the next section of the presentation, which includes Darwin Core's uses, importance, and implications. I think this quote from author environmentalist Wendell Berry says it all. Darwin Core supports researchers and scientists who are trying to save the Earth and understand the myriad of ways it affects us. Robertson et al. Explain in their article that the Earth is experiencing many different types of changes, from climate change to animal extinction. These changes affect the planet's biodiversity. One event leads to another, leads to another. In order to study the effects and even help predict future events, it's imperative that we have data that is easily understood and that can be readily shared. Baker, Rycroft, and Smith's article from 2014 explains that many biodiversity data was frequently published in formats that were not consistent across disciplines and that the terminology used wasn't standard. When information isn't easily set up to be reused by different people or programs, the information may get lost, become unused, and therefore may cause other problems down the line. For example, researchers may end up doing the same work, may incorrectly validate or invalidate their hypothesis based on unorganized data sharing, and may spend money duplicating efforts. So Darwin Core was made to mitigate these issues, and it's done a great job in doing so. A few slides back, I introduced you to Global Biodiversity Information Facility. They are an international network and data infrastructure funded by the world's governments and aimed at providing anyone, anywhere, open access to data about all types of life on Earth. The GBIF has over 60,000 data sets with over 1.5 billion records. They have a robust scientific community and even citizen scientists who are dedicated to researching Earth's biodiversity. Darwin Core is so easy to use and adaptable that even smaller organizations have found ways to use its metadata scheme. This screenshot is from the Fishes of Texas project, started in the late 1990s at UT Austin. The Fishes of Texas project was originally created to compile all Texas fish into a book. However, with the internet, the group focused on a website instead. The group has information on some fish and fish specimens as far back as the 1800s and from 40 institutions. The group not only compiled the data and standardized it using Darwin Core, they've spent years ensuring the validity of the data and georeferencing as much as possible. So this, of course, brings me back to my scenario. If you were a scientist now studying the blue tilapia, the Fishes of Texas database would save you so much time, effort, and money. Basic information like taxonomy, known locations, and even pictures are easily provided for you. You can download the Fishes of Texas dataset and study their information to aid in your research. Many hours are saved by knowing right away that the blue tilapia is also known as the tilapia aurea. This easy-to-read data means that if you relied on your phone calls to various institutions, as we did in the beginning, you might not have added all the data available to you. So Darwin Core is a simple and great foundational metadata scheme that allows scientists to easily share biodiversity data. Simple Darwin Core can be done only using Excel, and yet generic Darwin Core allows for greater flexibility with the addition of relational data. Its standards are updated by the scientific community, ensuring that only essential, suitable changes are made. It's actually such a useful and foundational tool that other scientists have created extensions to it for more specific biodiversity sharing, such as for gene banks, vernacular names, and DNA amplifications. And then lastly, my references. Thank you.